Hey guys, this is the part one video for this week. So I'm going to make two videos because they're related, but they're also kind of two different topics. So I want to, finish factoring officially by doing topic TAH here. And I wanted to give you a list of like things to look for as you work through problems. And I have a few example problems to show you for that too. But you'll notice starting over here on the end, yeah, over in this area. Step one is checking, is it in descending order and does it have any kind of greatest common factor that you could take out of the whole thing? So that's definitely one thing to work on or look at. After that, just looking at the number of terms that you have can give you a clue about things that you could try that might be a little easier than having to go through the entire process. So I have step two listed here as checking to see if it has 4 terms. And so the idea behind that would be if it does have 4 terms, um, you could try to factor by grouping. So I'm going to write that here. So sometimes that works, sometimes it doesn't. I will say on IXL, it's probably going to work. So if you have a 4-term polynomial that you're trying to factor in this topic, TAH, then it's probably going to be something you can factor by grouping. This third thing would be to check to see if it has 2 terms. And if it does have only 2 terms, you can check to see if both those terms are perfect squares. And if they are, and it has a subtraction in the middle, so it has to have all 3 parts, 2 terms, perfect square, subtraction in the middle. That's what we were talking about last week with using that idea of a difference of squares. All right, and then when you go on here, if that doesn't work, if you don't have 2 terms, then that must mean you have 3 terms. And so one thing you can check with the 3 terms is if it has perfect squares again. So this idea of both numbers on the front and the back being perfect squares. So the middle number doesn't have to be perfect, just the first number and the last number. But if both of those are perfect squares, then it might be a perfect square trinomial, which I'll do an example and I'll show you there's 2 different things it could be. So it has like a special factoring pattern. The last thing is if it has 3 terms, but there is none of that. So none of this is applicable. So it's just 3 terms. This is where you do the product and sum with that magic numbers idea of finding 2 numbers that multiply to be the product and add to be the sum, and then factor by grouping. So we factor by grouping. So this is, we did these last week. So this topic's going to have kind of a nice blend of all of these things. So this is kind of what I would check for. I would check through 1 through 4 before you move on to 5. The nice thing about 5 is 5 always works. It's just you can save yourself some steps or some difficulty sometimes with numbers if you do these first 4 things, or check for them at least. All right, so if we get out of this and just look through some examples. So if I'm looking here at this, this is one of those ones where I said it would have 4 terms. So if I'm looking through, I don't have any greatest common factor for the whole thing. And this isn't really descending order the same way because it's 4 terms. So I do have 4 terms, which means I should try to factor by grouping. So I'm going to guess you'll probably get some of these on IXL for sure. I saw a few when I was working through. So, you just go through each group and figure out what the greatest common factor for each group is. So hopefully you feel pretty comfortable with this so far. We've kind of practiced it a lot. The second example, so this is one of the ones where it has 2 terms. And if I check, there's a 4 and a 25. So both of those numbers are perfect squares. And in the middle is a subtraction. So all of the criteria fits for me being able to use my shortcut, my special case. And this special case is called a difference of squares. And the idea is that you set up your two binomials, right? You take the square root of each term. So 4u squared, so the square root of that is 4, oh, no, not 4u, is 2u, right? The square root is 2, and then u. And then the square root of 25 is 5. And then the reason that this has nothing in the middle, there's only two terms, there's a 0 term in the middle, is because one of these is a plus and one of these is a minus. So these both have different signs. So that's my answer. The next example here, if you look, this has 3 terms. But if I check 9 and 1, these are both perfect squares too. And this time it doesn't matter if it's plus or minus in the middle. And I'll show you the difference. So this is called a perfect square trinomial. Again, one of those special cases that we talked about. And it kind of works the same way. So I have 2, right? And I'm going to take the square root of each piece. So 9f squared, the square root is going to be 3f, and then 1 and 1. So the difference with the perfect square trinomial is that instead of having different signs in the middle, these are going to have the same sign. And the way I can tell what the same sign is by what this sign is. If this is a plus, then both of these are a plus. That's why this whole thing ends up with positives, is because all of this is positive. And since these are the same, really, I can write my answer as just writing one of them down with a square on the outside. This is technically fine. This is just more simplified. So pretty straightforward. And then this is really the same thing. So I picked an example that has the same type of situation. So 3 terms. And I have 25 and 16. So those are both perfect squares again. So it is the same type of situation. So again, it's perfect square trinomial. The difference, though, here is the sign. So if I go through and I fill in my 2 binomials, 25 r squared, so it's 5r, and then 16 is 4 and 4. And again, just like last time, these are going to be the same sign. But this time, since this is negative, I want these to subtract, right? Because 5 times this 5 here times that 4 at the end is going to give me a 20. And this 4 times 5 is going to give me 20. So when I subtract those, negative 20 minus 20, that's where I get that negative 4 or 40. So these this time are both going to be negative. So I could rewrite this more simply with a squared on the outside. So this answer is right. This answer is more simplified. All right. From here, I'm just going to start working through problems. These are just 3 terms, and they don't have any special qualities. So these are back to like that kind of step 5, where I'm just going to figure out the product and the sum. So the product is 7, and the sum is -8. So 2 numbers that multiply to be positive 7 and add to be -8. So if I figure out those 2 numbers are 1 and 7, but in order to make this here be negative, I need to make both of these negative. So the shortcut when this is a 1 out front is that I can just fill it in. So if I have n squared, it's n, and then here's going to be a -1 and a -7. So that was the shortcut. If it doesn't have a 1 in front, then I have to go through the longer process, factoring by grouping. So my product here would be -4, and the sum is -3 here in the middle. But this time, when I find my 2 numbers, so 1 and 4, I need to make sure they multiply to be negative. So one's going to be positive, one's going to be negative, and I need the sum to be negative. So if I go through and just kind of think about what those signs need to be, I need to have a +1 and a -4. But this time I have to rewrite my middle term. So it's going to be 2x squared plus 1x minus 4x minus 2. So I use these two numbers here to rewrite here in the middle for that. And then now you're just factoring by grouping. So back to that first example of taking the first two and the second two. Don't forget that means it's going to be a negative. So for this one, I'd have x out front, and then 2x plus 1, and then negative 2. All right, and I think the last example I had here is just one where, don't forget, you can check for greatest common factor. Make sure there's nothing that you can divide out of all of them, which in this case, I can definitely take a 2 out, right? But those are pretty large numbers, so probably want to double check to make sure that there isn't anything else I can take out of it. And I can definitely take a 3 out of all of them too. If I'm paying attention, I can do a 3. So let's say 6. Let's take a 6 out and see what happens. So I have 3h squared minus 14h plus 8. So that looks good. And then from here, I'd go through and do my product and sum. So now that I've finished step 1, which is that greatest common factor, now I go through and say, well, my product, just for the middle. So I'm just ignoring the 6 and putting it out front. So the product for this is 3 times 8, so positive 24, and the sum is negative 14. So two numbers that multiply to be 24, but add to be a negative 14. This is a good example of one you might need to like come over and think about like the different pairs. So if you did 1 times 24 or 2 times 12, and so hopefully here you can be like, oh, maybe I can work on that. So if I did negative 2 and negative 12, right, then I can make that work out. So, all right, so that's part 1. Now we're gonna, then after this, the part 2 video of this week is gonna be, how are we gonna use this factoring to help us with graphing? So let me know if you have questions. Definitely, you should, hopefully feel like you have a good handle on factoring by the time I put the next video out on Wednesday. All right. Good luck. Let me know if you have any questions.